Hello everyone, welcome to today's class, and in this class we are moving ahead with the nature of the affected tissues. Okay, we are studying some different types of injury and different injury which is inflicted by some specific type of tools and weapons. So in that series we are moving ahead with the nature of the affected tissue. So it is really very important to understand the nature of tissues, and on the basis of that nature different types of wounds are inflicted. For example, first is the skin. We are talking about the skin. The skin is radially changes shape when it is struck, as it is very pliable and little elastic. Okay, it is also resistant to transaction forces, and because of these factors often the skin is not damaged when stuck with the blunt instrument, although underlying structures may be severely damaged. So the skin is not that damaged, but underlying structures beneath the skin might get the damage. The skin may easily split when crushed against the rigid bone. So when the skin is crushed between the bones and the rigid structure or blunt instrument, the skin may split apart. Okay, and that's what happens with the skin because it has some little elasticity in it, and when it gets the force, and if there is some bone beneath the skin, then the skin will split apart. Okay, so this is upon the skin. Next we have the subcutaneous tissue. Subcutaneous tissues have elasticity and plasticity both. The subcutaneous tissues are very plastic due to fat content and pliability of connective tissue. Okay, so because of the fat content, our fat tissues are present at the subcutaneous tissue level. That's why it is elastic and plastic, due to which they protect the body by cushioning effect, and that's why our bones and our soft tissues are protected, because these fat content act as a cushion, right? So that's why it protects the underlying things, underlying organs and other things which they have on blow. So if the skin is having some blow, and because of the fat content, because of the fat tissues, because of the adipose tissues, it creates a cushioning effect. It is incompressible fat for the subcutaneous tissue. The incompressible fat of the subcutaneous tissues may be crushed and displaced between the skin and underlying structure, producing bruises due to severe blows from blunt instruments. So this thing is also known as Hooke's law of elasticity. Okay, if the skin is getting blunt forces, and because of that it will get a lot of bruises because of the pressure which is applied in the skin, and in the subcutaneous layer it causes the blue bruises, because it is not going to split apart or crushed, but it depends on the weapon, right? We are talking about blunt instruments. Okay, so blunt blows of instrument will create different types of bruises on the skin, and this is also known as Hooke's law of elasticity. Then we have the muscles. So first the skin, the subcutaneous tissues, and now we are moving with the muscles. The muscles are usually not damaged due to the blows. Okay, the blows is not going to damage the muscle because of their great plasticity and elasticity and their strong and encapsulating sheaths. So in tissues we have layers and layers of, in muscles we have layers and layers of muscles, and they are really very strong, and we have different layers and different sheets of muscles. That's why the blow is not going to break down your muscles. They may be crushed. Okay, they may be crushed against the bone or lacerated by fragments of displace the broken bone. So it might get lacerated or it might get crushed against the bone. The muscle may rupture if they are unduly stretched. So if the muscle is stretched beyond its capacity, then they will surely get ruptured. Okay, so we have different protein in the muscle, and it will give the great elasticity to the muscles, because when we move, our muscle gets contraction and relaxation in the course of movement. So that's why it already have some elasticity. But if we are stretching the muscle beyond its elasticity, it is going to be ruptured and it is going to be crushed against the bone. It is not going to get any effect in the simple blows. Okay, next we have the bones. When a force is applied to a bone, it may be bent without breaking. So if we are applying great force to the bones, it might get bent, but broken bone is a really very like hard phenomena, we can say. A simple blow or force is not going to break the bones, but it fractures when it is bent beyond its limit and its elasticity. So that is the like basic principle. When we are stretching or when we are applying force beyond its capacity or beyond something's capacity, then it's going to get the bad effects. Then we have body fluids. Fluid is incompressible, of course, but it is readily displaced. A blow over a hollow organ which contains fluid may set up a powerful hydrostatic force in that fluid, which are transmitted equally and uniformly to all directions, which may cause rupture of anatomically distant and mechanically weak tissues. So it is going to get the rupture if pressure is applied and that particular organ contains some fluid. So the blow and the transfer of energy will be equally distributed in all directions in that particular organ, and if that is a weak tissue, it's going to get the rupture. A sudden compression of the chest may rupture distal venules and capillaries as seen in traumatic asphyxia. Okay, so if someone is compressing the chest, then it might cause the traumatic asphyxia. The violent displacement of fluid in the gastrointestinal or urinary tract may cause distant ruptures of portions of these tracts. So these tracts might get the rupture, and which is not a good sign in case of injuries. Then we have gases. They are readily compressible. Lungs may be extensively compressed without any structural damage, but when lungs are compressed suddenly or violently, sufficiently powerful pneumatic forces may cause damage to the tissue, and it may end up having really very bad effects. Okay, then we have applications. So different wounds may be caused from equal forces when applied to the same region of the body in different circumstances. So for example, I am applying equal force to some particular region of the body, it might cause different wounds. Okay, sometimes minor forces may produce severe wounds and relatively severe forces might produce minor wounds. So this is a really very common phenomena to see. Because of these, often on scientific grounds, it is not possible to give an opinion as to amount of force which must have been used to cause a particular wound. So that's why we cannot say anything about the amount of force and the amount of force in some particular organs is required to make the wounds. It is also not possible to predict the amount of damage which could be caused by the application of certain force. So we cannot say anything about that as well. The doctor should give his opinion in broad qualified terms. That is what is required. Sometimes injuries of internal organs do not show any sign of external damage. Okay, so this is, again, I am saying this again and again, so it is evident till like by now. So that's about today's class, everyone. So this is the fourth this is the fourth point, the nature of the affected tissues. Okay, so we are done with all these 4 points. Okay, so first, the nature of object or instrument which causes the wound, amount of energy which is discharged during the impact, the condition under which the energy is discharged, and the nature of affected tissues like the skin, subcutaneous tissues, muscle, bone, and body fluid, along with gases. So we are done with this topic, everyone. I hope you like this video. If you like this video, you can click the like button, share it with your friends, seniors and juniors, and subscribe this new channel and support us. And if you have any question, query, or doubt, you can comment those down below in the comment section and we will address that. And if you want to join any of our coaching classes, which is available in our official application, link is in the description. If you want to connect with us through WhatsApp support number is again given in the description box, so do check that out. Thank you so much again everyone. See you guys in the next class. Till then, take care and bye.